Okay, so I'm going to just work on some support for some basic prefixes. So in volume 2A chapter 2, there's this instruction format section, and it describes some prefixes here. So specifically, I'll be adding support for lock, repeat not equals, and repeat equals. And I'll also be adding support for segment override prefixes. So these ones here are actually going to just be forms that I can omit, and these ones here will be operand decorators that I can apply to memory operands. So starting with these ones, lock and repeat, these are basically just emitting single bytes here. So we've got F0 for lock, F2 for repeat not equals, and then for repeat or repeat equals, we've got F3. They only apply to certain instructions, but it's not really going to be the encoder's job to check that you're doing that correctly. That will be like the job of a higher level assembler that will use the encoder as like one of its components. So all I need to do really is add some tests for these, and I can't actually add, for example, lock as its own single sort of like byte emission instruction here, because NASM will complain that I'm not applying it to a valid instruction. So what I need to do here is basically just output the bytes. So I know that this is 0f, for example. I know that these two, repeat not equals and repeat not 0, are going to be f2. And then I know that these ones will be f3. So this is basically all I need to do to test these prefixes. So if I just go to the encoder and we'll find the test for these. So we'll just go down to the bottom of this one. So here, for example, all I need to do is add an op. So this one will be, for example, lock, which is going to be 0, and then it's just going to have no operands at all. Same goes for REPNE and REPNZ. And then we'll also have just rep and REPE and REPZ as well. So actually, I need to split these out a bit more. That will do. So now let's just regenerate these listings. Okay, and then I should be able to run the tests, but this will fail because I haven't done the mnemonic constants yet. So let's just go and add those. This will be over here, op unknown. Let's add them at the top here. So we've got, I'll just copy them from here. These ones are prefix operations. And then we'll just add some forms for them. So these forms I'll just add to the top here. So they're all going to match on width 0. They're all going to be opNZO. And then they're basically just all going to output as an opcode. So, for example, lock was OX0F. This one was OXF2. And then these three were OXF3. Okay, width. Oh, I need to add an extra layer to these tables. Okay, so this is saying that it's okay. Yeah, so that looks fine. So now I can move on to the segment override prefixes. So in 64-bit mode, the only two that actually matter are FS and GS. These four here CS down to ES are actually set to 0 in 64-bit mode, which means that they're basically no ops and are pretty much just ignored. FS and GS are still actually used. So I'll add support for all of these because I might add support for 32-bit or 16-bit encoding in the future, for example. But when I generate these tests, NASM is probably going to complain about these top 4. So let's just take all of these into NASM. So we'll take all these names here, lowercase them. So we're basically going to use this to override the memory access. So we'll do this on RCX, and we'll use a MOV here. So we'll say MOV RAX and move from that memory source. Just to make sure that it works with vector as well, we'll do MOV apps with XMM0 and vmov apps for the vex encoding of this. Okay, so here we can see NASM is complaining about CSSS, DS, and ES in 64-bit mode, saying that they will be ignored. That's fine. It is still encoding them, so I can still test against this. And then this signed D-word warning is from a previous RIP relative test, which I can also ignore. Okay, so for the segment overrides, we'll basically have a new helper that takes a segment, which is going to be one of the flags. We'll say that if, for example, O is not memory, then we'll panic, saying that a segment override prefix can only be applied to memory operands. We'll also say, for example, that if O is any of the memory operands, so we'll just go and get these ones. Join them together, uppercase them. Okay, if it's any of these already, then we'll panic to say that operand already has a segment override prefix. We'll return 0 or return O, and then on O we'll just OR the segment into the info flags. So this is basically going to be treated as like a decorator here. So we'll put these in here. And then add them to the decorators so they don't participate in like the scoring of forms. Then we need tests. So let's just take these over to Encoder tests and put them below here. So I'll take these mnemonics, uppercase them, put them with op. They're mostly going to be keyword. With axcx.m.s, and then we need the segment name. So this will go into S over here as uppercase. These bottom two will be X word, and then we use V0 as the first operand. So let's run the tests. Too few values. Yes, so these also need NA, NA. Okay, so now we can see that we're getting the correct encoding, except the segment prefix is not being emitted right now. And the segment prefix comes before everything else, so even before the rex prefix. So to do that, I think I can just go to form family. So down here is where I'm emitting, for example, the rex prefix and the maps and things and the vex and evex prefixes and stuff. Basically, I can just put it here so that it applies to all of the form families, because even for vex and evex, it's still prepended as like just a full byte. So let's just go and get all of these names again. And we'll say, for example, if RM is one of these, Then we'll want to output one of these numbers. So let's just bring this in. So this will be e.code equals append e.code, ox, and then the number. So now if we run the test, everything passes. So that's prefixes. I did also just want to clean up test data a bit while I'm here. So let's go, for example, into here, and we'll just get rid of all of the existing listing files right now. And we'll get rid of all of these non-assembly files. Because basically this way that I've been organizing the test so far, it sort of made sense in the beginning, but I think it's not really giving me anything now. Instead, what I want to have is like an encoder 64-bit test, which just has everything in it. And then later on, I can use another test file if I want to implement, for example, 32-bit or 16-bit or something like that. So we'll just go into here and we'll just start with, let's just go through in order of how they're listed here. So we've got mod rm. We'll add everything to in order as I've got them tested. So we'll have test data, encoder 64-bit ASM. And then basically just add them in. So we've got mod rm1 here. So this can be added in there. Which means that I can change this to encoder 64-bit listing. The next one is mov SSE, so we'll just join these together. So we've got mov SSE here. This can now go onto the bottom of this file. Next is evex compressed disp 8. So we'll go to evex compressed disp 8, and we'll just dump all of these into here. I think that looks okay. Next is just the SSE vex evex one. Okay, and then we've got Leah. Then after Leah, we've got arithmetic. Then arithmetic SSE. Then bits. Then logical. Then the integer extensions. Shifts and rotates. conditionals. System and miscellaneous. Then stack and control flow. And that looks like it should be about it. So let's just make sure these tests actually work. I'll need to do NASM, code gen, test data, encoder 64-bit, and then just make the listing file. So we've got some warnings, which are all part of the tests, I think. So let's just go and check. Yeah, so this is like a deliberate, you know, making the RIP relative to the start of the next instruction instead of the beginning of the current instruction and stuff. So that's all fine. And then we've got the segment override warnings, which we've also said are fine. So that should be it. Let's just do a go test. Mismatch between test group cases and expectations. Let's just get this and do, so what we'll say n want is equal to this, and what we got is this. So we'll say want this many tests got this many tests. So we're missing a few tests now. So let me just check through here. Okay. Let's just go and get rid of all of these ones. Okay, let's just see, where is this failing? So we've got encoder tests. I think these should still be broken up roughly by the same number of blank lines. So let's see, for example, if we've got 860 lines is down to v comp ps. This one is 862. But there are some comments in here. We'll just put these on the other line here. So 860 goes down to v comp ps. Then let's say 1060. Let's go and see how many lines the Lear ones take up. So this is 1139. which is also fine. Then we'll go down to add PD, maybe. Uh, 1353, that's correct. Let's go down to TZ count. That's also fine. Then we got shift left. It looks like maybe we're missing here somewhere. So we've got SAR. Let's go to neg here. What about OR? Okay, BTS. Let's go to that one. Okay, so that one's okay. If we go to pop count. Oh, we're missing pop count. How did we miss that? Let's just put pop count back in here. I think it's the same. Okay, that's fine. I don't know how I missed pop count out of there, but that's all working now. So that's the tests cleared up, and I've added support for some prefix. So segment override prefixes and lock and repeat prefixes.